All right. Number 6. Ready? An equation gives us information that we can use to graph the function. Pick out the important information given in each of the following equations and use the information to graph the function.
Oh, I got it. -5?
Is what?
The y-axis.
Okay, good. So one of the important pieces in this equation is that -5 is the y-intercept. So that means I'm going to put a dot at -5. That's where I'm going to start my graph. Okay, so then the other important piece of this is that this is the slope. So from here I go up 1 over 2, up 1 over 2, and then connect the dots. With a straight line. Okay? So the things that we know from the equation that help you graph the function, Nathan says, are the y-intercept and the slope. Okay? Yeah. Yes. So even if it's not a fraction, you have to make it a fraction. So if, for example, the slope is 3, you make it into 3 over 1. Okay? Maybe. If it's not a fraction, you make it into 1. Okay? Okay, are we good with that? Yep. All right, next one. What do you know from the equation that helps you to graph this function? Huh? What is the y-intercept this time? Nope, it's not 2. What's the number in front of the 2? Yeah, the y-intercept is 1. So they did not write that 1 in there, but you can think of this as y equals 1 times 2 to the n. Okay? So the y-intercept is 1. What does the 2 tell you? Not really, because this is one of those curved ones, an exponential one. The 2 tells you that it doubles each time. Okay, so if it starts at 1 and it doubles, then the next one would be, if it starts at 1 and then it doubles, the next point would be at 2, and then the next point would be at 4, and then the next point would be at 8, and then it goes off the charts. Okay, if we're going to the left instead of doubling, what does it do? It doesn't double both ways, no. It's not a straight line because when it doubles, that means it gets steeper and steeper and steeper. So that means it's not going to be. 1 each time, and then goes up. Doubles when you go up. No, only goes, so it went from 0 to 1, 1 to 2, 2 to 3. So those are numbers are just increasing by 1. It's the y's that are doubling. Okay? Yeah. Yeah, and that's always going to, yeah, that's a good question. It's always going to go up by 1 no matter what this number is here. So it'll sideways go up by 1, and then this number here tells you what you multiply it by. Okay? Yeah. No, we finished, I think we finished the lesson 9 homework. Right. Okay, and then we started this lesson 10 notes. Yeah. Okay. What happens when we go the other way, to the other side? Yeah, it divides by 2. So this was 1. 1 divided by 2 is 1/2. 1/2 divided by 2 is 1/4. 1/4 divided by 2 is 1/8. 1/16, 1/32, 1/64, 1/128, 1/256, 1/512. So it looks like that. Okay? So we talked about that as you go to the left, that it's never going to hit the x-axis, because if you keep dividing something by 2, you'll never get to 0. Okay? How did I know it was going to be exponential? How did I know it wasn't going to be a straight line? Right. And exponential functions, of course, are curved. It seems silly for you to have dragged yourself from your deathbed and come to school and then just text while you're here. You know what I'm saying? Yeah, or you can just stay home and text Lindsay from there. Okay, any questions on that? Oh yeah, this is the review. For sure this is the review. Yeah. Okay. Kinda. Yeah. Right. One we're supposed to do together, one you're supposed to do on your own. Yeah, so maybe we need to just work towards changing that to where you actually can do it on your own. In class maybe, not as homework, but on your own. Yeah. Right, that's why I would give you time in class, yeah. On your own, but in class, right. Sharon? Wednesday? I don't know, just nothing. If we do something, I'll give you your test back and then we'll go us around. Yeah. Right. Right. Yeah. Right. I'm not giving up. I'm still want to go get to the place where after we do the notes together, you guys will be able to do more of it on your own. Yeah, I know, I get you. All right, number 8. Tricky one. You know from the equation. I do not know the y-intercept in this case. I have an equation. What's that? You could, but we can graph this without distributing it. This is a new form of the linear equation that we were learning last week. What point does this go through? -6, 8. Well played. Opposite inside the parentheses, outside the parentheses is regular, yeah. This one actually doesn't have the y-intercept because of the parentheses. So if it doesn't have parentheses, then you know it has the y-intercept. If it does, then you have to pick the point like Luis just did, yeah. Yep, good. And then the slope is -2. So for this one, instead of starting on the y-axis, I'm going to go to -6, 8. And then, Dylan, this is kind of what we were talking about before. This isn't a fraction, but I'm going to turn it into one. I'm going to make it -2 over 1. So from this point, I'm going to go down 2 over 1, down 2 over 1. And that will give me the points that I need. What's that? The y-intercept comes out to be -4? Yeah. Luis, how'd you get -6? Oh, never mind. Shot down. Where the -6 came from? The x coordinate of the point is inside the parentheses with the x, but it's the opposite of this. So if this is plus, then it's going to be minus. If this is minus, it's going to be plus. What's that? The -2 really doesn't have anything to do with this part right here. I could change the -2 into a 5, and it would still go through the point -6, 8. Okay? It's just the opposite of what it is to start with. So if I gave you y equals 3 times x minus 5 plus 7, what point would this go through? It would go through 5, 7. Yep, just because of math, yeah. Yeah. It doesn't matter, we're just focusing on the point. What point would this one go through? -2, -3. These two things right here. And then for this one, the slope would be -4. For this one over here, the slope is 3. Okay? Okay? Okay. Yep, it's weird. All right, last one. F of 1 equals -5. And to get the next one, you add 1 each time. So we start at... so this one you start at 1, -5. Because it says when you plug in 1, you get -5 as an answer. So 1, -5. That's what this part here means. F of 1 equals -5 means that when you plug in 1 for x, you get -5 for y as an answer. So I'm going to start right there. Okay? At, 1, -5. Okay? Then this is the formula about what to do from there. From there, I'm going to go up 1 each time. So over 1, up 1, over 1, up 1, over 1, up 1. And then that's it. Before, yes, we will. Because of this +1. Okay?
Yeah, I agree.
Sadly, that's not how this is supposed to go. There's certain stuff in this class that you're supposed to learn and just will pretend. Well, but the stuff that we're gonna learn later isn't easier than this. It gets true. Yeah, I know what you're saying. Yeah. Okay. Okay. So starting out with this here, I'll pass these out to you right now. If you have 2 different options for investing money. One of them is called simple interest, and what that means is that you just get interest based on how much money you invested in the very beginning, okay? And they're going to give you 10% interest per year. So they started the table for you. If you start out with $200, at year 0 you have, of course, $200. At the end of the first year, you have $220. Where did that come from? 10% of the 200 is 20, so that means they gave you $20 interest, okay? Simple interest, again, they're always just going to give you interest based on your initial deposit. So how much do you get in interest for the next year? Right, this is going to be $240 because you get another free $20. What will the next one be? $260, $280, and $300. And that is called simple interest. Okay? What we've mostly been doing is called compound interest. So in this case, you're going to get 8% per year. Okay? 200 times 1.08. Right. So what does that give you? Okay, so after 1 year, you've got 216. And then if you multiply that by 233 and 80 cents. Oh, and 28. Okay. 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 Awesome, thank you. So in this one, we were multiplying by 1.08 each time. And in this one here, since it's simple interest, we are just adding 20 each time. Right? Does that make sense? Okay. All right. So, which of the graphs below best shows how Mary's money will grow in each bank? So, which one of those would be the simple savings account, and which one of those would be the compound capital account? Jaron? Okay, awesome. Graph B is the simple, and graph A is the compound. Okay? How did you know that? Okay. Yeah, going up by the same amount each time. Yeah, great word, constant. This one has a constant slope. It's going up by $20 each year. This one has an increasing slope. It's getting steeper and steeper and steeper. And this one is totally out of the question. Okay, does that make sense? No, so C is neither one of those. It's there just to trick you. All right, write down a formula for calculating the amount of money in each of these banks after n years. So we have simple, and we have compound. Okay, so write down a formula for each one of those. Like Louis said, simple, you're adding each time. So the formula would be the $200 that you started with plus the $20 interest you get each year. 200 plus 20 n.
I had 200 and plus 20.
Okay.
That work?
No. Sorry. The compound one, you're starting with 200, and what are you doing to that each time? 1.08 to the nth power, because you're multiplying by 1.08 each time. Okay? So those are the two different ones. Those are the two formulas that you guys need to know how to do for the test tomorrow. If it's going up by the same amount each time, you take your starting point plus whatever it's going up by times the variable. If it's a percent one, you take your starting point times that to the nth power. Dylan? how to get a percent into a decimal? Give me a percent. Okay, so 5% is 0.05. You move the decimal over 2 places. You divide by 100. That's what percent means. It means per 100. There's 100, pennies in a. There's 100 cents in a dollar. There's 100 centuries in a year. So it's per cent. It's 0.05. Yeah. Okay. No, 8% is 0.08. The reason why the 1 is there is because you have to multiply the original money also. So the 0.08 is the interest that you get, and the 1 is the money that you invested to start with. Yeah, pretty much. Yeah. Nathan, you're getting everybody sick really fast. Okay, Mary wants to invest some money for 5 years. Let's just figure it out for 5 years. Which one would she choose? Okay, so Matthew claims that after 5 years she should choose simple because she would have more money then. Do you agree? Sure. If you look at the table that at the very beginning, after 5 years with a simple interest, she's got $300. After 5 years with the compound interest, only $293.07. Okay. What if it was more years? Compound. This one's going to catch up eventually. Okay. After 1 year, it was behind by $4. After 7 years, it's $2 ahead. So this would be $3.20, and then this would be $3.40. And you did the other two? Uh-huh. Okay. Okay. All right, so after 5 years, the simple interest would be better, but if you stayed with it for much longer, then you're saying compound interest would be the way to go. Okay. Right. I mean, depending. Right. And do we really ever know how much time we have, Matthew? All right, so up here on the board, we've got 3 different types of investments. This is like the old Sesame Street game. One of these is not like the other. Which one of these do you think doesn't fit? Investment 3, why? Okay, so Nathan says investment 3 doesn't fit because the interest rate is higher. Okay. Yes? No, you don't have this. You think what? You think number 1, but you don't know why? What is 5% of 100? What would you get in investment 1? $5. So this one you would get $5 interest each year. What is 5% of 400? 20. Nicely done. So then you would get $20 here. What is 10% of 200? $20. So is that what you were thinking, Jaron? This one ends up having less interest per month. Right. Yeah. Okay, so you could argue that investment 1 is the one that sticks out because you only get...
Put more, if you put more.
True. If you had put more in, then you would end up getting more than you would out of investment 2. But in this case, since this is all we got, that is another way to look at it, okay? What is the formula for this? Nope, this is simple interest, so you can just plus 5n. What is the, that's okay, what's the 400 plus, nope. How much do you get each month for this one? 20n. I'm sorry, I didn't hear you. What's the formula for this one? 200 plus, what's this one? 20n, okay? So in the simple interest formula, this number right here is not the percent. It's the percent of the original money, right? Okay? Nathan, you got Talia sick amazingly fast.
No, I got mistake.
Okay, so how could we use, how could we use those formulas to figure out how much would be in the bank in each case after 5 years? Plug 5 in for n. Good. So if I plug 5 in for n in this one, how much will we have? Right, we would have gotten $25 in interest because 5 times 5 is 25. So we would have $125 in there. If you plug 5 in for n here, you would have 500 because 5 times 20 is $100 interest, so you'd have $500. And if we plug 5 in for n here, then we would have $300. Okay? So those are all simple interest ones. Those are linear. It's going up by the same amount each time. Okay? All right, let's start again. Which one of these does not belong? Why does investment 1 not belong? Okay, so Nathan's looking at this, and he says this one you're investing for 4 years, whereas this one and this one you're only investing for 2 years. Okay, so Nathan says number 1 is the odd one out.
No, I mean, okay, by the look of it, it's the odd one out, but investment 3, that is going up by,
Okay, another way that you could look at it is this one you only get 3% interest. What percent interest do you get on these two? 6% interest. So if you look at it that way, then number 3 is the odd one out. And then what? Okay, good. Then this one and this one both start with 500, whereas this one you start with $250. And so if you wanted to, you could say that investment number 2 was the odd one out. Okay? So it just depends on how you look at it. This one has a different starting number. This one has a different number of years, and this one has a lower interest rate. Okay? So they are all different in their own ways. All right? How do you know that this is compound interest, not simple interest? Because you're multiplying. Good. The simple interest you add each time. Compound interest you multiply. Okay? All right. We talked about those already. We can figure that out. Okay. So what I'm going to do right now is I'm going to give you